Testing again. Oh, there we go. Am I live? I see myself in YouTube. Okay, welcome friends. Oh, how do I see if there are any friends? 0 viewers. All right. Well, tonight I don't have a ton of energy, so I thought I would, well, in addition to working up the courage to start the stream, thought I would try to do some a compiler warning, so an unused variable warning, because it's something I kind of want to have, and I want to sort of explore the warning system a bit. So yeah, let's get to it. Let me see, let me set up my windows over here so that I can see what's up. Got chat here, kind of. All right, I can kind of see chat. I'll try and keep my mic close because it sounds much better. Maybe I can keep it here. Maybe the cable won't be in the way. All right, let me do one more thing. Let me tweet about this stream. How would I share? Share. There we go. This is what you do, right? You post on your social media that you're live. All right, I tweeped. All right, not leaking any secrets. Let's go. So, unused variable warnings. The program, let's first write let's build the LSP so that it works, and we'll write a program. I think I already wrote one that doesn't use one of its function arguments. So I want to do let bindings and I want to do function arguments. Those are the main ones. So there's also globals. Unused global is interesting because if you're like building a library, then it may be for linking. So you may not ever want to use it, but I don't have syntax for saying like this is an exported symbol yet anyway, so we don't need to worry about that. I'll just open up simple here, and yeah, we have an unused here. There is an LSP connected to this, so if I were to say ASDF, that's not defined. So we will see warnings here if we implement them, which might be the goal of the stream. Maybe let's say 30 minutes. See if we can get warnings showing. Now let me just check if anyone is watching. Zero. That's okay. All right, cool. A lot of other warnings I want to implement, some stuff to do with pattern matching, not using a generic type parameter, not using a type bound, like a type class bound, things like that. Anyway, just dealing with this cable here. All right. So let's get in there. What I want to do, I have a place where I, a function where I type check function bodies. So if we go back here, this is a variable. I know the ID of every variable, every function parameter has a variable ID. I know all of those, so I think that when I've just finished type checking the whole function is the perfect time to do this for function parameters. I think that for let bindings, we're going to do something similar. where the moment we finish that block, we'll check if for unused let bindings belonging to that block. I want to be really conscious of doing extra passes through all the code because the point of this compiler is to be really fast. So yeah, want to just be thoughtful about doing this stuff efficiently, not having really any material cost to it. All right, so here's where we evaluate function bodies. And we check that it matches the type that the function returns. I think that, yeah, probably right here is where we're going to want to do this. So at this point, maybe after type checking. So if there's a body, we could do it here. And we want to get the function. So we might even do and that's a slice handle. Type program, so this will be self-mem get in. This is my my own like memory arena for like just the primary space for the type checker, and we'll do iter. So there we go. And what I want to do for now is I just want to print and this will be denster name usage count. So I did add usage count earlier today, but I have not tested it at all. We have no idea if it's working correctly. Yeah. Let's just start there. All right. So even though we didn't write a lot of code, we just compiled and type checked our entire standard library. All right, mode usages. So here's alloc usages. This is nice. All right. So what we're looking for is, yep. So in compiling our simple.k1 here, we actually compiled 3 modules. The way the compiler works is there is core, and then there's standard, and then there is the thing that you're compiling, or any of its dependencies if you declare them. So really, once we get to the 3rd module, loading module simple, this is after we have loaded and type checked core and standard. So this means that here is going to be tough. So unused usages. So let's go ahead and do this. Let's have used twice f32, and this will be let y equals used twice plus used twice. Let's run again. 0, used twice usage is 4. Okay. I don't know why I would be checking this function twice. So we might have just found a pretty juicy bug. We're going to see 2 here. No, 1. Okay. Oh, I think I know. So the way addition is implemented here is this is getting compiled to a type class call. Let's do this. Ability add. So in core, which we've already compiled, right? Which we talked about, we have add. And this needs to get solved for because like ability calls support generics. They get pretty complex and like ability constraints as well. So we end up getting a generic solve, which means that we would evaluate these expressions twice because you end up with something like add/add, and this is of type, I don't know, 1. And this is also, I don't know, 1, like mystery 1. And then this whole thing returns, mystery 1, and then we solve. So then we like actually run this variable expression and get to resolve it, right? Okay, we know that it's an F32. And so this thing will run this expression and then this expression. And then, as part of inference, basically. So we're actually gonna, compile the expression used twice, 2 times while solving, and then we're gonna learn that, okay, this whole thing is definitely add for F32. And then once we know the F32, I actually am gonna compile this entire call again, passing in the type hints of everything that we know the types are supposed to be. And what this does is this gets you like maximally good like inference and behavior and no funny business. So essentially what I'm saying is for all generic code, I compile everything twice, which sounds bad, but if compiling things is very fast, it's kind of worth it. And the alternative is, I think, doing a inference pass that's almost the same thing. So anyway, it's a bit of a bummer that something as simple as plus involves inference and solves, but it was worth it to do it as an ability call. So it's interesting. So that's a total digression there, more than you ever wanted to know. Let me zoom this in about how. See if we have no chat about how that resolves. But then 4 is what we expect to see there. So let me just go ahead and run it again. It's called used twice. It's actually going to get used 4 times. Yep, if we want it used twice, then let's do this. So we'll call it F. Let's compile it again. It should be used twice. Unused use is 0. So, and there's another thing I have, something called context. Env, we'll just say env, type string, and I'll say let context and string equals stuff. Env. All right, and now we're gonna call foo. And it wants a byte, so we'll do 3, and it wants an F32. 3.14 is my favorite, and that works. Now, if I didn't have a context string declared, then there's no context parameter of type string. So the reason I do that is because that's sort of a different code path, different type of variable, and I want to see, and it does get loaded in here. It is never used, but if this thing said my env is env, let's return x plus x just for fun. Okay, my env. So now it's used. It's used once. The only thing that's unused is unused. Feel pretty good about this. Just to show you, since I implemented this off screen, typed parsed expr variable, eval variable. So every time we see a variable from the AST, parsing the code, we know it's a variable reference. This is the code that runs, and it's pretty much just as simple as if we don't find it, variable not found. There's some stuff for captures because I do lambdas, I do closures capturing lambdas. So it could be that, and then there's a lot of bookkeeping and stuff to do for that. But if it's not a capture, then all I'm doing is creating a variable expr where I say, hey, the thing was this variable ID, this is its type, so that anything looking at that expression knows its type. And then I'm just incrementing the usage count on that variable ID. So that is literally it. And let's do this. And we're gonna report warning. Let's report error. Just for kicks. So I'll go irf. We always have irf. And then what variable is this? Do you have a span? No, that's an ID. And variables don't know their spans. So let where would the span live? Param. So this function, the function has its type params. The params live in the function type. Function type, physical params. I'm looking for a span. There. Okay. We're after that. So instead of this, I'm going to go with let f here, and this can be f.param variables, and now we've got f param function type ID expect function type. Okay, we now have a function type. Function type has physical params. That's a slice handle. This will be types. Mem get nth index param variables. Yep. Param index. Okay, so what did we just do? We just asked for, we just looked up like the record of this function parameter itself, because that talks about where in the source code it appears, because I want to underline it. So that's the fun param type. Param type, we can say, and then this can be param type dot span, and then this can be function, let's say parameter. Parameter is never used. Is it parameter is never used, or is it parameter is never used? I'm not sure. Self.denster param type probably has a name on it. Name. We like that. Yeah, that's horribly frustrating, actually. The nice thing about everything being interned in like a memory pool with a handle is you don't actually have to really have borrows for very long. You're only like one memory lookup away. So there we go. Now we can have exclusive access to self even within this loop, which is pretty rare in Rust. Like you usually end up pretty hosed with when you're doing this kind of stuff eventually. But I've got, this thing is a tiny copy type that represents how to get to this slice of fun param types. So I can carry it around all day long without the borrow checker caring, and then I can always just basically dereference it. Anyone here? Hello? All good. We can run then. Okay, so to C string. Actually, okay, this is just, I think, exposing some of the bugs where I don't increment the count. Yeah, if it's passed as a context param. So what do we want to do? Do we want to, I mean, all we wanted to do was report the error. We reported the error. So let's fix it. So this is context parameters, and you see it's correctly working if I use it, but what's not happening is if foo were to call a function that needed context env and I found it and used it, that's not getting counted as a usage. So that's pretty simple. There's one place where we decide what's getting passed to a function, and that is align call arguments with parameters, which sort of says, hey, here's a function call that we parsed. The function takes these params. This is for synthesized code, so we don't worry about it. The function takes these params. Yeah, so like here's what the user typed, here's what the function takes, like figure it out. And we've got context params and matching context variable. If I found a matching context variable, then I'm saying I'm pushing that, so that is a usage, and I'm making a variable expr. So I wonder if like we could have a helper that's like add variable expr, and that would increase the usages, but this is actually fine. I don't mind explicitly doing it, because it's also kind of weird. You want to be able to make stuff, like I want to be able to make an expression maybe like tentatively, or maybe like it doesn't end up in the final program because maybe that compilation doesn't work out. I don't want the usages to be increased from that, right? And I don't want like transactional things. So better to do something like this. It's kind of like user facing, only like explicitly, if that makes sense, so that, you know, other code can like make variable expressions without messing up statistics, if that makes sense. That's kind of how I'm thinking about it. And yeah, there's always a trade-off with like, yeah, do the bookkeeping in the helper. It's like, okay, but then it's hidden, and there's some downsides to that, and you can have bugs. But on the other hand, if you don't, and you say, just do the bookkeeping everywhere it needs to be done, then of course you can forget. So I kind of prefer do it everywhere it needs to be done and have tests, or run your code, test your code, right? Should be okay. Because this, like if this got removed, and then like all of this code would stop compiling again. So, you know, we should be fine. And that's kind of it. Okay, we went from 40 to 19 errors, and now we're back to 2C string. Let's actually go there, string.k1. All right, 139. Do I call anyone who needs an allocator? Penchar. No, because we're calling enlarge clone, but not enlarge clone in. So it just uses the currently active allocator. And I want to change all of this eventually, but that's fine. For now, I call a penchar here, and I call it in 2 tests. Let me just add a companion. I've kind of been doing this. Penchar in, context alloc. So that's like saying what allocator you want to use, and then this would be a penchar penchar in, and I'm going to say context alloc mode. No. Dot current. Yeah, you can't set the mode to current, but you can pass current, and then self. C. Does that make sense? So there's a penchar which just works, and it just says, hey, I want to do the thing that's parameterized on allocator with the current, and then this one actually takes the allocator, which needs to call enlarged clone in, enlarged clone in. Yes, which does exist. So that should be good. And then now if we go back to a 2C string, it's now using its alloc mode because it's going to call pchar. Okay. 19 errors. 18 errors. These are pretty magical, pretty special case type of argument, these function parameters. So it makes sense that it thinks it's not used. Interesting. This one's weird. If not value. Hi, Ahmed. What do you mean by my role? So what I'm thinking about right now is I'm thinking about why this would show up as not used. Oh, okay. Something wrong with assert maybe. Okay, that's a good one. I like that. It's not going to be an error, by the way. So maybe we name it underscore. This just takes a type. That's interesting. Yep, just a typo. So I thought I might find a few of these. So this would be array/size bytes. Yeah. Now, this lets you call it with dot, because you can say self.size bytes. Interesting. So yeah, maybe it's intended. I will need a way to dismiss this warning. That one is good. That one is good. Yeah, interesting. So kind of a mix of correct and incorrect. Let's look at assert. So it's passed to not, but that doesn't seem. I can't see how that would do it. Oh, I'm definitely going to do the underscore name thing. It would be, you name it underscore t instead of just underscore. That's definitely going to be the move. Sep is never used. String. Fun join. Joining. Interesting. Yeah, it's not. And we could be getting some weird stuff because of how much other stuff is failing to compile. Although it doesn't really make sense to me. Assert's kind of getting me, but yeah, so I guess let's check if the name starts with an underscore. I can just go ahead and do that right now. And that's how I want to check it, and I don't see a reason to track that. Like, I can just compute that. So var name stir, then stir param type name. Yep, only if the usage count is 0. We do this extra work. All right, and this will need to be factored out into some sort of, this logic will want to go out because we need to do this not just for function parameters, right? But also for lets and stuff. And this is something that needs to be shared. So now we can go to fun discard and we can name this underscore t. We can check we had 18. And now we have 17. Here we go. Grow. Grow doesn't use its allocator. Reserve. Reserve needs to just always reserve in. Okay, we only call it twice. Let's just take it explicitly. And we should import it. No. Why doesn't that work? So okay. Hmm. 17. 17. Okay, so far these are all function type params. Assert's still here. This one makes no sense to me. Let's try removing the not. Okay, it wasn't that. Nothing to do with the unary thing. Obviously, I could say value. Still 14. That's weird. Let's go all the way to the bottom. Fun assert. Parameters never used value. What? And it's both parameters to this thing. And crash does take a context location. So what? Function, body block. Going through the param variables, we're definitely looking at context ones. The fact that this didn't fix it is wild to me. Can I write a function like this in simple? My assert. Just to clean things up here, now that we've got the errors, we're not going to get past. Let's make it a warning. Report error. Report warning. It's not working because earth. So earth, we need warmth, I guess. Make error. Yeah. Is that right? Make just assumes error. Yeah, I've never used the error type, so we'll do a make warning. Fine. Type of error make. Is that even what I want to call? Ugh. Message span. No, not really. Make, oh, it's only called in. All right, so let's just fix make. Error level. Warning. How long have we been going? 40 minutes. All right, we're compiling again. Write error. Level name. Warning. It's not coming through with the right level. And the color should be, yeah, come on. It's supposed to be yellow. Oh. Report warning. Never called this function before, so give me a break. Report warning. So I'm calling report warning. I'm calling report warning, but with earth, right? Because my thing says error. So, oh, it's kind of weird, right? Like, because it's in the error and it's in in the function name. So it should probably just stay report error. What I wanted to do is I wanted to push it to a different vec just to avoid having to rewrite things that, you know, because if there's any presence of errors, there's a lot of things that depend on that. Shit. We'll do this for now. Can I merge you, and then can I and then let's just warnings just for a minute. Let's just go non-errors, and my thing is lagging hard, so I think I'm gonna restart. I don't know why it starts doing that. All right, still coming through as errors because I'm doing ERF. So usage count, come on, come on. Yep, this is the one where I think it's not really worth it for now. Probably will get rid of it. But you gotta just try things out for a bit. Oh, I've never seen this yellow before. Cool. The underlines are the wrong color. Nice. And they're mostly right, except for the very wrong ones. Okay, an array is never used here. These few I can fix, but let's fix it. Let's worry about it later, right? Here's another case where we're doing the same thing. You pass a value as a more convenient way of passing it, essentially just passing a type. Okay. Unused is never used, but this thing isn't suffering from the assert problem. Assert is not, right? Unused. Unit. Am I crazy? Unused. So this is the same shape. So it's something with assert itself, yeah? Or it's not that we never call assert. This doesn't care at all if the function's ever called. What could it be? All right, so maybe we do clean these up a bit, so it's easier to go through them. Get type name of val. Discard, we did. Example equals for unit. This is such a funny function. Oh, I can't name it underscore self. Or can I? Oh, it doesn't care what I name it, I hope. Let's go. Oh, I don't get a count of warnings. These are all function type params so far. Fun join. I don't even know if this thing's used. Join. in K1 code, in K1 code. Ah, it wanted new lines. Ah, okay. Right, string, sep. I think that's right. Pred, fun assert. Size bytes. So we're down, it's down to you and it is down to me. Oh, I'm not printing the counts anymore. Let's try this. So back in Typer, what we could do is print the counts. I do have a function name. I'm not sure this is going to tell me anything because I know there's 0. There's not even, assert's not even a special function. Right? What? Like, what could it be? What? Let's just action creates information, right? So let's just do some stuff. Let's print them for now. Let me fix you. Not getting any errors. Yeah, What we probably end up doing is renaming this to report, and we rename typer error to like typer, I hate diagnostic, message, right? And then it's just like, okay, here's your messages, instead of calling them errors. I can go ahead and do that actually, at least for the report part. Okay, so it's the first, what's going on here with assert? Uh-huh. What? Something funny going on here. And it doesn't happen to assert DBG, right? Like, that is so fishy. What? What? Uh-huh. Sure. Okay, array. It's weird that this prints out. Here's our body. Eval x per inner value. Evaluating that should increase the count. We compile to this. It's all fine. And then it all goes into a return. But none of that should matter. None of that. I'm going crazy. Okay. Happens to assert to. Happens to find. What do you do? Let's do this instead. What? Okay, now that's wild, right? This isn't running for assert, so it's never getting usages. Wait, but no. Yeah, well, I didn't actually. Oh, these are fun. See the discarded ones. This is crazy, crazy, crazy. Assert only value. Assert DBG. Oh. Are they sharing? They are sharing a function type. They're sharing a function type, so they are sharing a span. Ah. Okay. This is the unused one, because what happens is we conditionally, I mean, it's been staring me in the face the whole time. We conditionally compile this one out, And yeah, so let me explain. You know how I had to grab the span, so the source code location, from the type of the function param? Well, we deduplicate types in this compiler, like to save space and be efficient. Like you don't need the type option of int to exist in your like type database 10 million times. So, but we dedupe all types. We even dedupe function signatures for the same reasons. But that means I shouldn't use them for source locations at all. What I should do is go grab it from the parsed function. But anyway, what that means is the error all along has been here, and it's actually working great, because if we don't compile this, then those aren't used, because we're not compiling in debug mode. But, so we're not getting the warning count. Let's get a warning count from add module, maybe at the very end. Yeah, I'd like to do it maybe from compiler, add module after core stud, main, print timing info. For now, I'll just print them here. If p non-errors this is what LLMs are for. No. This would be K1 typer compiler typer right. No, I've already reported them. Mission completed. Completed. This is just for now. That's all we care about. There it is. 11 warnings. 9 warnings, yeah. All right, so spans, huh? Or I could just go into the types. Not hashing the span. See this? Is it the same function parameter? Type. Param spans. I don't know. I could just point to the entire signature. Let's do that. I had this signature span. Signature span. Hello. How long is the delay, by the way? I just saw your message. Hello. Because if it's long, I will switch it to the other mode. They offer a few different modes. One is supposed to be faster. It lives on parsed function. Okay. Do I have the parsed function? Ha ha ha! You're in a huge function like this, you never know if you already have the let you need. About 1 minute. That's kind of a long time for something like this. But it said that the video quality would be higher in this mode, and I imagine pretty much everyone would watch a recording instead of watching live. So, but maybe I'll adjust it. We'll see how the quality looks. So am I okay? Am I okay with these two function signatures being the same? Fun assert and assert dbg. I have no idea how I'm going to not emit this warning for this conditional compilation thing. I guess. I mean, Rust seems to have this problem too. I'm not really sure what you do. You could mark it used. I could put an else in here and just discard. We'll just put a note that I'll probably never find. This excludes only span, which means actually means we should probably just remove the span. I just don't know if there's a reliable way to get from a function type parameter back to the parse tree, because there's things like lambdas that like introduce parameters that aren't in the parse tree, and then there's the context params. That's my role. I've been a software engineer for most of my career, and now I'm an software engineering leader. But this is just a personal project. Which means we should probably just take it off. Who uses it? Oh! Damn. Okay. Oh, wow. Parse function span. We pull everything off except. Really? We don't? Okay. I'm okay with that. Where were we? Yes. So this is kind of like making the software worse, but it's just like, it's removing some risk, and then I can always get the spans back if I want them in a more robust way. So that's some of the usages, and then here your fun param.span. This is for a fun param type. Do I have the parsed? Do I have the parsed one? Fun arc def. Yeah, okay, no, that's the parsed one. This is setting it. Fun param type. This is setting it. Setting it. Setting it. Setting it. Setting it. Yep, we have an ASP span, so that's fine. Well, so the way you get such knowledge is just by doing projects. And so this is a specialization that I don't actually have, which is compiler development and programming languages. I mean, you could argue that I have it. It depends on from which side of the equation you're looking at it. Yeah, I'm just trying to learn by building a really large, like multi-year project. I'm going to leave it in there for now. Another fix me. Determine if span even belongs. We ignore it in hashing. Is useful for let's just say fix me remove span from here. It's really not part of the type. We can get to signature param signature spans via another path. What I'd like to do is make another language all on YouTube. Maybe like one of those Carpathy style videos. It's like or one of those yeah, like Free Code Camp has like entire courses in one video. Sometimes they're like 20 hours. That would be really fun. Well, I don't really want to make a course. I want to work on my project. So it's a different thing than spending time building a course for Udemy. Although I would love to do that one day. I just don't have anything to teach until I get good, which is why I have to do the work. Okay, so I'm no longer worried about assert DBG. And the span is fixed too. We just underline the entire span now. See? So then it's very obvious. I could have logged the function name in here as well instead of relying on the span, and that would have worked as well. Okay. Let's fix size bytes. Dot size bytes. Does anyone call it? That's not an array. That is an array. That is a buffer. So this is the only place it's called, which is great in array.memset. Right? Yes. Okay. That is good enough for me. All right. Let's fix this color, shall we? Right? Error. right source location, level. So where are my thingies? My thingies, dot red, dot color, color. Yo, ready? Ready for some yellow? That's nice. It's just a warning. Just a warning, bro. Yeah, it would be so much better to underline the actual unused parameter. Okay, so the solution, typed function. What am I doing? The solution, I think, I have two parallel slices that I represent the function parameters in. So it's like this thing, you know, this thing has 3 parameters, and unused and used twice. I do, there's an array on the function called param variables, which is just variable IDs, right? But this could become really just the params, which is like var ID, and then also we have the span, right? Span ID, so that I have the locations. But then also function foo has a type. So foo.type, and that's a function type. Function types are their own thing, and they've got params. So you kind of want, but you don't want any information to be repeated here. Like I don't want the type ID here because, you know, then they could disagree and it's wasteful. So you're split across like the things you want to know about these function params. Some of it belongs in the type of the function, and you really want that to be a function type, not just like, yeah, because if you have lambdas and things and functions are types that you can manipulate or you could pass functions around, then you really want the function to have a function type, so that if I just like say, you know, get me the address of foo, now I have a pointer to, you know, the thing with the right type. So you want the function's type to fully represent the params, but you also want some more info that you need for like to do the rest of the compilation for bookkeeping. In this case, I have a variable ID that does tons of heavy lifting, so I think I need a span here. So what that would mean is param variables really just becomes params. So it's, you know, something pub struct typed function param, a simple pub variable ID, and then this pub span. Okay. And then it's our span ID. What we're doing is we're replacing param variables with typed function params, and then this is now just go rename params. Right, it's a slice of those. Now we can refactor this, factem slice param variables. We will leave it alone, and then when I push to you, I now have to push something else. I have to push a typed function param with a variable ID, a span, and I feel like I would have just removed the span. It's arg.span, and now typed arg, what? Gross. Oh, it's named args. So here I'm assuming that I can just iterate over the typed args again, but I don't have the spans. Shit. So I need you. I can zip with this. Yeah, I guess I can zip with this. Zip. Parsed arg. Right? This is just this is one push per, yeah. Every time typed params push. We don't put anything else in typed params. I come down here. Yep, we're just creating the variables because now we have a scope, and this would be parsed arg. Extra work. Typed function param. I know you are. Yeah, v dot variable ID. Ooh, okay, and then there's an insert thing. And the span is just going to be like body span for this one because it's fake. It's fake news. It's synthesized. What span am I using for this delightful little conversion? Call span. Oh, that's weird. It's doing it where, yeah, it feels like I'd rather use the function span. That's the call span. Ah, that is being used. Okay. By whom? Okay. Good. That's what I would have hoped to find. Oh, wow. All right, so what's your fun param span? Fantastic. Just check which function this is. This is regular function declaration. Cool. How many more of these do we have? Just these two. And we're done. And now, signature span, we don't have to do that because we have param variable and param dot span. Look at that. Now let's check a few places. Signature span. I think I ended up using this for main checks that could have been better. This is param types. Param variables, I can use param variables 0 now. And you were param variables 1, because you have one. All right, that wants to be the whole signature, so that's improved. You're not param variables anymore. You're just params. All right. Right, just wanted to save. This is actually just param. What I'm meaning to do is make it copy of it. For now, we're still fine. Variable ID, it's actually just param. Nope, it's not just param, it's typed param. Oh my gosh. Wait, what am I doing? What? Variable ID of okay, but it's not going to be the srep param. Right. We're in our LLVM backend now. I mean, I can just do this. Okay. Sure. It's actually param. Holy. All right. And now what happens? Boom. We have these things to handle. Because they're not variables. But they have variables. Boom. And then there we go. So the only one left. Yep. We're really close. We just have now these things. And so this is like a type of call, resolve. Yeah, well, let's resolve a function call. The thing we're calling. Yeah, we get down here and we're doing all sorts of fancy calls. Function variable. I think these guys would count as function variables, and if they get called, that's a use of the variable. Oh, and we're even synthesizing variable exprs. Oh, well, that's how you know, right? Types.get, and what type is it? Just an FTP. So it's these that aren't, but it would probably be the same if you used a lambda. So the variable ID, so for all of these OK branches, so we get down to here, and this is what? That's a result. Yeah. Variable ID, variable ID. Yep, you're doing the same. All of these end up with an expression that does use variable ID, and they're all OKs. And this one is not found. So what I think we can do, yeah. Well, even if we fail, the variable was definitely used, right? I wouldn't want to also report that it wasn't used. Let's do that, just like. All right, we can't hold on to a mute, but we can. Let's just say it got used. Even if it's gonna fail to resolve, because I don't know if we get down here, I think we would be in, oh, what? Oh. Are you serious? Fun not found, and I use fun not found in 2 places, 3 places. We're gonna do it this way. Macro rules. Yep. Sure are. Voila. So now that this isn't a value and a closure that borrows self, then what I really want to do is just run this code every time. I don't actually want the closure. So, this little macro is perfect here. And what did that do? That removed the rest of them. 3 warnings, 1 in here, and then we have assert dbg, which is our final boss. And what I can do here on the conditional compilation, we can go else here, and we can just say lock in value. Right, so it was a semicolon. Something like this. Aww. Why? They are used now. Okay, yeah. Something with parsing precedence. Well, there you go. The only unused thing we have left is our actually unused thing in our test, which we can underscore here. And we got no unused warnings. I am pretty happy with that. Let's clean up our print line, usage count. And so what we will want to do is basically from here, these f params gets us to a list of variable IDs. And then from a list of variable IDs, or for a single variable ID, like this is what we will factor out into something like function check usage, check no usage. But it's really important that I don't factor it out now because I haven't written the other usage of it. The other time, I know I'm going to want this again, but I haven't written that one yet. So I don't actually have, this is the least I'll ever know about the reusable version of it. So leave it here, right? Go do, this was function parameters. I want to do let bindings. Let's test closures though. Let's test closures. X, Y. I can't ever remember the syntax. I think it's just that. X plus X. Y should be unused. Come on. Y is not unused. Why not? So be like make does work. It's a regular function parameter, variable ID. Oh, because I'm doing eval function body, and I'm not sure that function gets called for lambdas. We call into the same code, but yeah, I need to call it from lambdas. So hit that. But anyway, next I'm going to do let bindings. So like when a let's unused, and it's going to be a little bit different, and I'm going to learn something, and then, you know, probably pull the code out then. Anyway, I think that's all. I've got to go to bed. Until next time.